as we raise the level of difficulty for adding and subtracting radical expressions, we're still going to check the same conditions that we had previously. Do we have the same index on both of the radicals, and do we have the same radicands? As we mentioned before, identifying the same index is the easy part. You can see in this example that these are both cube roots. The more challenging aspect is going to be to get these radicands to match. We see that both of the radicands have a y squared. That's a good place to start. Now we need to handle this issue with the x's, where this x is raised to the fourth power and this x is only raised to the first power. That's where the cube root comes into play. I'm going to take the cube root of just this part of the term right here, just this x to the fourth. Taking the cube root of x to the fourth, as we've discussed in previous lessons, just leaves us with an x out here. It also leaves us with an x on the inside because there were 4 of them and I used up 3 of them to make that. And it leaves us with a y squared that we never touched. And now we have our 2 radicands matching. And now we're able to add them together. So that cube root took up 3 of the x's that were on the inside of this expression and gave us an x out front and left an x behind inside the radicand. So adding them together, we know that the radicand isn't going to change with addition and subtraction. And we look to those 2 terms that are in the front of each of the radicands as where we're going to do our addition. Here we have 9x. In our next example, we're going to check the same things. We're going to check to see that our radicands are the same and our indices are the same. We have the same index, that's the square root, but we again don't have the same radicand. So we look for those things that we can simplify. This one has nothing that we can simplify. There's nothing to go there. So our goal is going to be to get this one to look like the one that's already in a simpler form. So we'll leave our 8 out here and we'll look at this 45. And because we're taking the square root, I'm going to look for perfect squares that go into 45. So I split it as 9 and 5. Taking the square root of that 9 leaves me with a 3 on the outside, and that 5 I'm going to need in there. But in order to get these to match, I'm going to need to leave an x in there as well. And that's where this x cubed comes into play. Because if I take this x cubed, and I imagine splitting it as x squared and root x, there's the root x that's going to stay in there, and then the square root of x squared is just x. So I simplified what I could on the inside to make the radicand match the radicand in the back half of the problem. Out here, I have a multiplication that I can do that will leave me with 24x root 5x plus root 5x. Now, before we try to add the 2 of these together, I'm going to have a little sidebar over here, and I'm going to ask you to consider this example if we wanted to add these 2 terms together. Well, at first glance, it would be a little bit difficult to add these 2 together without remembering that there is a 1 in front of this term. These 2 terms have a common factor of x, and we can rewrite that expression like that. The same thing is going to happen over here. These 2 have a common factor of root 5x. This one is being multiplied by 24x, and this one is being multiplied by that 1 that's there. 24x plus 1 times root 5x. So on occasion, when we're trying to combine these radicals, we have to get creative in the way that we do it. And one of the ways that we get creative with it is by reminding ourselves of those rules for combining like terms. Here we have another example where the indices are the same, but our radicands are different. If we look carefully at this cube root over here on the right, we notice that there is nothing that I can do in here. This power is a 2. The power on the y is a 1. Both of those are less than 3, so there's nothing that I can simplify over here. The best I'm going to be able to do is that that entire part of the expression stays exactly the same. All of the work that I'm going to have to engage is going to have to happen in here to make it match the other one. Now, fortunately, this question was designed to work that way, so we should see some pretty significant simplifications. Let's start by going cube root on every one of the factors on the inside. So let's go cube root of 125. Well, that's just 5. That's one we should know. We're going to take the cube root of x to the 11th. Well, the cube root of x to the 11th is x to the 11 thirds, which is x to the 3 2/3, putting 3 x's out here and 2 x's on the inside, which is exactly what we wanted to have happen. And then our y is going to be done similarly. So it's y to the 7/3, which is y to the 2 1/3, putting 2 y's out here and leaving 1 y left over on the inside. Now our radicands match. So we know that that's our common factor, cube root x squared y. And what are each of those factors being multiplied by? 5x cubed y squared and 8. So they'll make up our factor in the front. So while the basic rule doesn't change, make sure the index is the same, make sure the radicand is the same, questions that seemingly don't look like there's going to be any combining that you could do at all end up being very combinable, a lot of simplifying can happen, and you can clean them up a lot, even if we end up with this sort of distributive property and reverse factorization view of the answer. We still had this common factor of the cube root or the square root or whatever the example is that we're able to write outside of those two terms in the front of each.